Chapter 7. Ionic Equilibria. 7.1 Acid and Bases. Salt hydrolysis. The learning outcomes for this lesson are, to explain qualitatively salt hydrolysis using hydrolysis equations and classify the salts formed from the reaction between A. Strong acid and strong base, B. Strong acid and weak base, C. Weak acid and strong base. In this video you will first learn about salts from strong acid and strong base. Firstly, you must know what is salt. Let's take a look at this video.
Salts are formed in neutralization reactions occurring between an acid and a base. Therefore, salts should exhibit neither acidic nor basic properties. Indeed, solutions of many salts, such as sodium chloride, have neutral pH. But if we measure the pH of ammonium chloride solution, it turns out that the solution is acidic. In contrast, sodium acetate solution is alkaline. In today's lesson, you will discover the causes of this phenomenon.
So salt is actually an ionic compound that formed by the neutralization reaction between an acid and a base to produce salt and water. The positive ion of the salt is from the base while its negative ion is from the acid. Salt can be classified as neutral, acidic and basic salt in aqueous solution as they undergo a process called hydrolysis. We can determine if the salt is neutral, acidic or basic based on the strength of acid and base. So what exactly is salt hydrolysis? Salt hydrolysis is a chemical reaction between anion or cation from a salt with water molecules. The pH of the solution depends whether the cation or anion from the salt is hydrolyzed. Let's take a look at the general equation for neutralization reaction, where when a base reacts with an acid, they will produce salt and water. Then this salt, Mx, will then dissociate in water to produce cation, M positive, and anion, X negative. If the cation is chosen to be hydrolyzed with water, it will produce more hydronium ions, H3O+, which lead to the pH value decrease. While if the anion is chosen to be hydrolyzed with water, it will produce more hydroxide ions, OH-, which then increase the value of pH. Now let's take a look at salts from strong acid and weak base. Both cation and anion from this salt do not hydrolyzes, because both ions are conjugates of strong base and strong acid. For example, sodium chloride, potassium nitrate, and sodium sulfate. The pH of the salt solution is 7, at 25 degrees Celsius. Let's look at an example of salt hydrolysis from this salt. We take sodium chloride as an example. Sodium chloride is formed from sodium hydroxide reacts with hydrochloric acid, where the sodium hydroxide is a strong base, while the hydrochloric acid is a strong acid. When the sodium chloride dissolves in water, it will produce sodium ion, Na+, and chloride ion, Cl-. Both ions are not hydrolyzed with water. So, there is no production of extra hydronium ions, and hydroxide ions, which make both concentrations are the same. Hence, the solution or the salt formed is neutral. Now you try for salt, potassium sulfate, K2SO4. Firstly, you need to write the dissociation equation for potassium sulfate. Potassium sulfate when dissociate in water, it will produce potassium ion, K+, and sulfate ion, SO4, 2-. Some hint, K+ ions, is from potassium hydroxide, which is strong base, while SO4, 2- ions, is from sulfuric acid, which is strong acid. Therefore, both ions do not hydrolyze with water, as both are conjugates of strong acid and base. Both concentration hydronium ion and hydroxide ion are still the same, which result the pH is 7. Hence, potassium sulfate is a neutral salt. Thank you for watching this video, Salt Hydrolysis Part 1.